Connecting a ceiling light using 14-gauge Romex from a 20-amp protected receptacle is indeed questionable. This is because the National Electrical Code, or NEC, addresses the requirements for receptacle outlets and their associated branch circuit ratings. NEC Table 402.5 stipulates that receptacle outlets must be connected to a branch circuit rated not less than 15 amps. The implication of this requirement is that the receptacle in question should ideally be part of a 15-amp circuit, not a 20-amp circuit. This discrepancy creates a potential for overloading the 14-gauge Romex. Here's a breakdown of the key concepts and the reasoning behind the code requirement. Firstly, branch circuit rating. A branch circuit is the circuit conductors between the final overcurrent device protecting the circuit and the outlet or outlets. The overcurrent device, typically a circuit breaker or fuse, is designed to protect the circuit wiring from overloads and short circuits. The rating of the branch circuit is determined by the ampacity of the conductors, the rating of the overcurrent device, and the types of loads served. Secondly, receptacle outlet requirements. The NEC mandates that receptacle outlets must be supplied by branch circuits with a minimum rating of 15 amps. This requirement aims to ensure that receptacles can safely supply power to various loads without exceeding the capacity of the branch circuit wiring. The reason for this requirement is to provide a reasonable level of safety and prevent overloading of the circuit. Thirdly, conductor ampacity. Ampacity refers to the current carrying capacity of a conductor, expressed in amps. The ampacity of a conductor is determined by its size, material, insulation type, and installation conditions. The NEC provides tables that specify the allowable ampacities for different types of conductors under various conditions. For example, 14-gauge copper wire, commonly used in residential wiring, typically has an ampacity of 15 amps under normal conditions. Fourthly, overload protection. Overload protection is the function of an overcurrent device, such as a circuit breaker or fuse, to protect a circuit from excessive current flow. When the current in a circuit exceeds the rating of the overcurrent device, the device will trip, interrupting the circuit and preventing damage to the wiring and equipment. Fifthly, the issue with 20-amp receptacles and 14-gauge wire. The problem arises when a 20-amp receptacle is used on a circuit wired with 14-gauge Romex. While the 20-amp circuit breaker will protect the circuit from overloads exceeding 20 amps, it will not protect the 14-gauge wire from overloads between 15 amps and 20 amps. This is because the 14-gauge wire is only rated for 15 amps. If a device plugged into the 20-amp receptacle draws more than 15 amps but less than 20 amps, the 14-gauge wire could overheat, potentially causing a fire hazard. Sixthly, NEC compliance. To comply with the NEC, receptacle outlet should be matched with the appropriate branch circuit rating and conductor size. If a 20-amp receptacle is used, the branch circuit wiring must be at least 12-gauge copper wire, which has an ampacity of 20 amps under normal conditions. Conversely, if 14-gauge wire is used, the receptacle outlet should be on a 15-amp circuit. Seventhly, the scenario with the ceiling light. In the specific scenario described, where a ceiling light is being fed with 14-gauge Romex from a 20-amp receptacle, the situation is questionable because the 14-gauge wire is not adequately protected by the 20-amp circuit breaker. While the ceiling light itself may not draw more than 15 amps, the potential exists for someone to plug a higher amperage device into the receptacle, which could overload the 14-gauge wire. Eighthly, the importance of safety. Electrical safety is paramount, and it is essential to adhere to the NEC guidelines to prevent electrical hazards. Using the correct wire size and overcurrent protection for each circuit is crucial for ensuring the safety of the electrical system and protecting people and property from fire and electrical shock. Ninthly, potential solutions. Several solutions can address the situation. Firstly, replace the 20-amp receptacle with a 15-amp receptacle. This will ensure that only devices drawing 15 amps or less can be plugged into the receptacle, protecting the 14-gauge wire from overload. Secondly, replace the 20-amp circuit breaker with a 15-amp circuit breaker. This will provide overload protection for the 14-gauge wire, preventing it from overheating. Thirdly, replace the 14-gauge wire with 12-gauge wire. This will allow the use of a 20 amp receptacle and circuit breaker while ensuring that the wiring is adequately protected. 10. Best practices. It is always a good practice to consult with a qualified electrician to ensure that electrical work is performed safely and in accordance with the NEC. A qualified electrician can assess the existing wiring, determine the appropriate circuit ratings, and recommend the best solutions for ensuring electrical safety. In summary, while it may seem convenient to tap into an existing 20 amp receptacle to power a ceiling light, doing so with 14 gauge Romex is questionable from a safety and code compliance standpoint. The NEC requires receptacle outlets to be on circuits rated at least 15 amps, and the 14 gauge wire is only rated for 15 amps. This discrepancy creates the potential for overloading the wire and causing a fire hazard. To resolve this issue, consider replacing the receptacle, circuit breaker, or wiring to ensure that the circuit is properly protected and meets the NEC requirements. Always prioritize electrical safety and consult with a qualified electrician when in doubt. The NEC, or National Electrical Code, plays a vital role in ensuring electrical safety throughout the United States. It is a comprehensive set of standards and guidelines that govern the installation and maintenance of electrical systems. The code is developed and updated every 3 years by the National Fire Protection Association, or NFPA, to reflect the latest advancements in electrical technology and safety practices. Understanding and adhering to the NEC is crucial for electricians, contractors, and homeowners alike. It provides a framework for safe and reliable electrical installations, minimizing the risk of electrical hazards such as fires, shocks, and electrocution. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, equipment installation, and special occupancies. It specifies the minimum requirements for electrical systems, ensuring that they are designed, installed, and maintained in a safe and effective manner. One of the key principles of the NEC is to protect people and property from electrical hazards. It achieves this by establishing requirements for conductor sizing, overcurrent protection, grounding, and other safety measures. The code also addresses specific hazards associated with different types of electrical equipment and installations, such as swimming pools, spas, and hazardous locations. The NEC is not a law itself, but it is widely adopted by state and local jurisdictions as the basis for their electrical codes. This means that electrical installations must comply with the NEC requirements in order to be considered safe and legal. Local electrical inspectors enforce the NEC and have the authority to approve or reject electrical installations based on their compliance with the code. It is important to note that the NEC is a minimum standard. While compliance with the NEC will help ensure electrical safety, it is not a substitute for good workmanship and sound engineering practices. Electricians and contractors should always strive to exceed the minimum requirements of the NEC and to incorporate best practices in their electrical work. The NEC is a complex and comprehensive document, and it can be challenging to navigate. However, it is essential for anyone involved in electrical work to have a thorough understanding of the code. There are many resources available to help people learn about the NEC, including training courses, seminars, and online resources. Electricians and contractors should also stay up to date on the latest changes to the NEC, as the code is updated every 3 years. One of the most important aspects of the NEC is its focus on overcurrent protection. Overcurrent protection is the function of an overcurrent device, such as a circuit breaker or fuse, to protect a circuit from excessive current flow. When the current in a circuit exceeds the rating of the overcurrent device, the device will trip, interrupting the circuit and preventing damage to the wiring and equipment. The NEC specifies the type and size of overcurrent protection required for different types of circuits and equipment. It also requires that overcurrent devices be readily accessible and properly labeled. Another important aspect of the NEC is its focus on grounding. Grounding is the process of connecting electrical equipment and systems to the earth. Grounding provides a low impedance path for fault current to flow back to the source, which helps to trip the overcurrent device and clear the fault. The NEC specifies the requirements for grounding electrodes, grounding conductors, and bonding. It also addresses the grounding of specific types of equipment, such as motors, transformers, and generators. The NEC also covers wiring methods, which are the ways in which electrical conductors are installed and protected. The NEC specifies the types of wiring methods that are permitted for different applications, such as conduit, cable, and raceway. It also addresses the installation of wiring in different environments, such as wet locations, hazardous locations, and underground installations. The NEC is a valuable resource for anyone involved in electrical work. By understanding and adhering to the code, electricians, contractors, and homeowners can help ensure the safety and reliability of electrical systems. It is essential to stay up to date on the latest changes to the NEC and to consult with a qualified electrician when in doubt. In the specific scenario, the concern about using 14-gauge Romex on a 20-amp circuit stems from the potential for overloading the wire. While the 20-amp circuit breaker will protect the circuit from overloads exceeding 20 amps, it will not protect the 14-gauge wire from overloads between 15 amps and 20 amps. This is because the 14-gauge wire is only rated for 15 amps. If a device plugged into the receptacle draws more than 15 amps but less than 20 amps, the 14-gauge wire could overheat, potentially causing a fire hazard. To address this concern, there are several options available. Firstly, the 20-amp receptacle could be replaced with a 15-amp receptacle. This would prevent anyone from plugging in a device that draws more than 15 amps, protecting the 14-gauge wire from overload. Secondly, the 20-amp circuit breaker could be replaced with a 15-amp circuit breaker. This would provide overload protection for the 14-gauge wire, preventing it from overheating. Thirdly, the 14-gauge wire could be replaced with 12-gauge wire. This would allow the use of a 20-amp receptacle and circuit breaker while ensuring that the wiring is adequately protected. It is important to consider the specific application and the expected load when choosing the appropriate wiring method and overcurrent protection. In general, it is always best to err on the side of caution and to use larger wire and smaller overcurrent protection than is strictly required by the NEC. This will provide an extra margin of safety and help to prevent electrical hazards. In addition to the NEC, there may be other local codes and regulations that apply to electrical installations. It is important to check with the local building department to determine the specific requirements in your area. Electrical work should always be performed by a qualified electrician who is familiar with the NEC and local codes. A qualified electrician will have the knowledge and experience to ensure that the electrical installation is safe and compliant with all applicable regulations. In conclusion, using 14-gauge Romex on a 20-amp circuit is generally not recommended and may violate the NEC. The 14-gauge wire is only rated for 15 amps, and a 20-amp circuit breaker will not protect it from overloads between 15 amps and 20 amps. To address this concern, consider replacing the receptacle, circuit breaker, or wiring to ensure that the circuit is properly protected and meets the NEC requirements. Always prioritize electrical safety and consult with a qualified electrician when in doubt.